back, my fellow assassins, to another episode of the Dark Assassins Podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. If you want to make your life a heck of a lot easier as a software engineer or a software developer, design systems with deterministic outcomes. In other words, if this, then that. And I guess a simpler way to put it is if I give you this input, then I should be guaranteed to get this output. And the more ambiguity you introduce into your system, the more that ethics can potentially play a role depending on what your system is trying to accomplish. Plus, the nice thing about deterministic systems is they're much easier and simpler to test against and basically verify that you implemented it correctly and it's performing as you would expect it to, because you can just simply give it the input and it should return the output that you're expecting. But modern systems today, they're becoming less and less deterministic. And this is very evident in things like self-driving cars, general artificial intelligence, certain forms of robotics and whatnot. And all of these systems are very much non-deterministic. In other words, because something happens, because they get a certain input, does not mean they're always going to give you the same output. And I guess us humans are kind of like that too, depending on the circumstances and what kind of stimuli we're subjected to. We're not always going to react in the same way. For instance, if you stub your toe in your house by yourself, you might say some words that you might not say if you stubbed your toe and there were other people around, for instance. So, in essence, that is a good example of a non-deterministic situation, because the input was the same, you stubbed your toe, but the output, the words that you said, were not the same. Now, granted, you could make the argument that the input was slightly different because there were people around in the one scenario and they weren't in the other scenario, but we're going off the main input that you stubbed your toe. So all this to say, when you're talking about non-deterministic systems in cases like our modern day, ethics kind of take I won't say a front stage, because it's not often that people think about them, but they definitely play a role in how these systems behave, and certain ethic dilemmas can potentially come into play when designing these systems. So that's kind of what I want to touch on in this week's episode. But before we get into that, let's start off with our trivia question for the week. So this week's trivia question is: the original x86 Intel chips, or the 8086 and 8080, had a total of how many different instructions that they could perform? So how many original or different instructions could the original Intel x86 chips perform? And that is your trivia question for the week. Now, before we get into the cybersecurity tip, I did want to address a pretty funny meme I saw this week. And speaking of the whole non-deterministic solutions and systems, like with whole Gen AI. So I'm sure most of you, if you haven't seen, are familiar with the Spider-Man meme, where there's one Spider-Man pointing at the other Spider-Man, kind of like accusing each other. And then there's, of course, other instances where you have like tons of these Spider-Mans all pointing at each other. So That's the meme. And in the middle, it says my broken code. And then one Spider Man pointing says Stack Overflow copy paste. Another Spider Man pointing says handwritten code. Another Spider Man pointing says bad training data. And the fourth Spider Man says Gen AI hallucinations. So all of those contributing factors to my broken code, which I thought was absolutely hilarious because that's basically how it is, especially if you are using AI solutions to help you write your code. You are probably well aware that that is very much a reality. But even if you take that out, like the handwritten code and Stack Overflow copy pastes, even that is still pretty darn hilarious. So I just thought I would share that. But now let's get into this week's cybersecurity tip. Honestly, we should just completely scrap this segment and rename it to What is the latest Cisco 10 out of 10 CVE? Because while we had a little bit of a reprieve last week with no new vulnerabilities, Cisco is back at it again this week with another 10 out of 10 perfect score CVE for remote code execution. So this marks the third out of 4 weeks where Cisco has had at least one of these. And if we're taking the average, the total number of these 10 out of 10 CVEs, they're averaging one perfect 10 per week over the last 4 weeks, which is not a statistic that you want to have by any means. You want that number to be as close to zero as possible. So the fact that they're averaging a one in the past 4 weeks is not exactly a very good thing. So yeah, maybe take an informal poll here. Should we rename the cybersecurity tip to what is the latest Cisco 10 out of 10 CVE? Because at that point, that's literally what the segment has been pretty much for the past almost month, if you will. Because aside from 1 week, Cisco has had a perfect 10 out of 10 CVE for us to talk about. And yeah, so we had a little. I guess they maybe wanted to give us a little bit of a break, maybe or whatever. I don't know. Maybe the whole team decided that they were gonna go take a week off for summer vacation or something, and now they're back to work this week and have another one. I don't know what's going on with Cisco. But I guess to address Cisco, if they are listening, which fair enough, they are not. But if they are, if anyone that works at Cisco is listening to this, um, I understand that I'm giving you a lot of free publicity here, covering all of your CVEs. But could you maybe just write code that isn't so critically vulnerable? I think specifically your customers, I think would greatly appreciate that because having to, be mindful of, okay, what Cisco patches do I need to patch this week for the latest 10 out of 10 security vulnerability that could potentially have remote code execution happening on my Cisco gear. So while some would say that all publicity is good publicity, the fact that all this publicity is over all of your 10 out of 10 CVEs that you've been having over the past few weeks, that's not exactly the stellar image that you want to be putting forth, especially when you're trying to sell yourself as, this big enterprise brand that's like the staple in, enterprise networking and basically the gold standard. You're kind of chipping away at that solid gold standard reputation with all of these vulnerabilities. It's really not that good of a look. Okay, so what is this week's vulnerability in Cisco land? Well, this week's vulnerability impacts Cisco's Identity Service Engine, or ISE, and Cisco's Passive Identity Connector. And basically, it could permit an attacker to execute arbitrary code on the underlying operating system with elevated privileges. Clap, clap, clap. Remote code execution as root. Love to see it. So Cisco had this to say on the vulnerability. quote, multiple vulnerabilities in a specific API of Cisco ISE and Cisco ISE PIC could allow an unauthenticated remote attacker to execute arbitrary code on the underlying operating system as root. The attacker does not require any valid credentials to exploit these vulnerabilities. These vulnerabilities are due to insufficient validation of user supplied input. An attacker could exploit these vulnerabilities by submitting a crafted API request. A successful exploit could allow the attacker to obtain root privileges on the affected device. Cisco, buddy, how many times have we been over this? Yet another instance of failing to validate your user supplied input. How many? I think this is I honestly, I've lost track because there have been so many, but I'm pretty sure at least the majority, if not all, of the past CVEs we've talked about with Cisco have been basically for this exact thing. Them basically not parsing user input properly and attackers being able to exploit that and exploit get remote code execution as root. So again, I know I've beat this dead horse to death extensively over the course of this podcast and especially over the past few weeks. So I'm sorry I'm beating this dead horse again, but apparently I haven't beat it enough because those folks at Cisco haven't got the memo yet, that when it comes to writing secure code, you always, 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 always assume that the input the user provides you is malicious unless you have proven otherwise that it is not. So, whenever you're dealing with user input, your first step should always be to validate it and check it to make sure it's what you expect. This should include things like bounds checking, make sure it's not too big, obviously not putting it into a fixed size buffer because then buffer overflow, making sure it's not malformed in any way, making sure all the parameters it's supposed to have exist, making sure the parameters that are there are actually valid. Things like this, basic steps to just make sure that the input you're getting is legitimate before you then send it through whatever other functions and API backend stuff is required to actually perform the task that the user is wanting to do. Now, does that accrue a performance hit? Technically, yes. But I would argue the performance hit is worth not getting attackers exploiting your systems and executing whatever code they want to as root. I think that's a worthy trade-off, but maybe you might not think so. But that's okay. You can just be wrong, and that's fine. But it's getting to the point where Cisco has had so many of these failing to validate user supplied input issues that honestly I think we might have to rename the whole vulnerability and issue of failing to validate user input and causing remote code execution as pulling a Cisco, because they're becoming so notorious for it these days that one, it's a lot simpler just to say, oh, you're pulling a Cisco there, or oh, you pulled a Cisco. Plus, with how ubiquitous it's becoming, with how many times they've done it, it might even be in the common person lexicon that they just know that, oh yeah, Cisco, yeah, they're the ones that don't validate user input and have the ability for attackers to do remote code execution and stuff. Yeah, them. So maybe we should just refer to this going forward as pulling a Cisco, because honestly, they're getting quite good at it. I mean, I don't know if they're necessarily trying to be good at it. I mean, this isn't something you want to be good at, let's be clear. But they are doing a pretty good job of being pretty good at it. Now, according to the evidence out there, there is no current evidence to suggest that this current vulnerability has been exploited in the wild, or at least exploited maliciously. I'm sure security researchers, when they were trying to find this vulnerability, did exploit it, but it at least hasn't been exploited maliciously in the wild, at least according to the evidence available now. And yeah, but it just keeps happening. So I guess again, for the third out of the fourth week, patch your Cisco systems because patches are available. Um, so yeah, yeah, kind of sad to see. But I guess again, the other tip here too is to always make sure that you are validating and your user input before you do anything with it. And that is your cybersecurity tip for the week. Moving right along, let's get into what nerdy stuff have I been up to this week. So last week I talked about getting the being able to implement the early stages of being able to swap items in the bag menu for the Pokemon game I'm working on. But the big issue that I didn't solve last week was the fact that you had no idea what item you actually selected. So if you selected an item, there was no indication that you selected that item or which item was selected. So if you're kind of scrolling up and down through the bag and you forgot which item you selected, there'd really be no way for you to know which item you selected, which obviously is not ideal, and that's not how the actual Pokemon games work. So this week I set out to actually fix that. So I got the arrow depicting what item you had selected in the bag working, and that was pretty nice. It kind of has the little graying effect, and it kind of stays in place and kind of moves up and down. Make sure it stays with the item you're looking for, and if when that item goes off the screen, of course the arrow goes away, and then when it comes back into view, the arrow obviously comes back. So that's all working good. I did end up refactoring a decent amount of the code that relates to how displaying arrows and those kinds of menus work, because previously it was specifically just for the main arrow, but I didn't want to rewrite a bunch of code because that's very wasteful, both the waste of my time and of space. So I just refactored the code to basically have the function take in a couple more parameters to basically account for, is this basically the arrow depicting that an item was selected, or if this just the generic arrow doing the selection. And of course, have default values set for all those. Basically, the default is the arrow pointing to an item that has been selected, just by default doesn't exist because most times it won't exist. So that was pretty good. The trickiest part, honestly, for getting this functionality to work was getting the arrow to stay in place, and basically moving with the item that's moving. Because one of the things with the bag menu is it's obviously a fixed windowed size, so you can only display so many items at a time. So obviously, if you just set the arrow to point to the specific index in the bag, it's probably not going to be in the right spot. And of course, once you start moving your index in the bag of going through different items, that index is going to change, and it's just going to be all out of whack and not work. The only time where it would work is if you had the exact proper number of items to fully fit the screen and none more. Then in that case, you can just set it to the index in the bag and everything will be fine. But of course, that's not thoroughly testing the system. So the example that I have in place for my testing purposes has intentionally a lot more items than that, so I do actually have to scroll through it to basically make sure that functionality works. So honestly, the hardest part was actually making sure that the arrow moves when it's supposed to move, stays when it's supposed to stay, and then disappears when the item that has been selected isn't being displayed anymore on the screen. Wasn't necessarily too difficult to actually figure out. It was mainly just kind of playing around with the math involved to kind of manipulate the index to make sure it's kind of displaying in the right spot. But aside from that, it wasn't too bad. So now the moving items in the bag feature is basically completely implemented at this point. I don't think there's really anything else that needs to be done with it. So definitely very happy with that. So now it's actually usable. You can select an item and you can actually see what item you selected to know what item you're going to be moving where. So very happy to get that done. Now, with that, I guess let us move into the main topic for the episode, that being the whole idea of ethics in designing systems. So, when it comes to, I guess, designing systems, personally, I am a big fan of deterministic systems, as I kind of said at the very beginning of the episode. And the reason why I like deterministic systems so much is because it's very easy to tell if you got the right answer, because the more ambiguity and more randomness you throw into the system, the harder it is to test. So, for instance, one of the things in my Pokemon game actually that I had to encounter and test to make sure it works was the encounter tables. I believe we talked about that maybe a couple months ago on the podcast. But essentially, how that worked is it based on a random weight value, it'll basically weight the random encounter that it'll generate. So, for instance, you could, rather than just be completely random, uniform distribution, you could basically weight it to say 40% of the time I want you to generate this, 20% of the time generate this, 10% of the time generate that, and then 10% of the time generate this other thing. So testing that is rather difficult because it's inherently random and therefore non-deterministic. Now, if you knew the seed going into it, you could theoretically calculate what you're actually going to be generating and can do it that way. But the simplest kind of version is basically generate a ton of encounters and basically just calculate how many times each one occurred and basically check to see if the weight matches up. But even this isn't necessarily a foolproof solution because after all it is random, there is a chance that depending on how many times you're running this, you still could essentially get the quote unquote wrong result and fail the test case. So this is why I went through the whole process of basically adding a retry mechanism, because while the number of times I was running it, which I want to say is around like 10,000 or so, or I think it was 10,000. It was either 10,000 or 100,000. I don't remember. It was a lot. But the thing of it was, every now and then it would fail on me, even though I do have like some wiggle room in there. Like, as I don't remember the exact wiggle room. I think it's like if you round the number up, or you basically do the ceiling, or you round it fully down, take the floor. If you round either one of those and you get this value, you're fine, and you pass the test. But every now and then, because it's inherently random, one of those would fail, and then it'd be like, oh, your test case failed. And it's like, well, I mean, no, not really, but okay, fine. So that's why I kind of added the retry mechanism. Now, it doesn't fail much, but it's enough to, I guess, be annoying. And that inherently is the problem with non-deterministic systems, because you don't know what you're gonna get when you run the system given an input. So it makes it significantly harder to reliably test to make sure it's functioning like it's supposed to be. So this is kind of where we get into the various states of, I guess, AI and just in general how systems are designed. So obviously you have the autonomous systems like self-driving cars, and the whole general artificial intelligence things that are out now, like your large language models, your image generators, your music generators, video generators are now becoming a thing too. So all of these different systems are inherently non-deterministic because that's just the nature of how they are. Now, I guess to go in a little more on why I like deterministic systems so much better, and is because you can make a very, very smart artificial intelligence with a fully deterministic system. And if you don't believe me, play a game of chess against a computer and set it to hard mode. If you've never played chess before, you're going to get your butt whooped and the computer's going to look like an absolute genius. And the thing of it is, it's not like the computer is well, I mean, maybe in some newer implementations, but in the old days when people were creating chess bots to play chess with, they weren't using some artificial intelligence neural network shenanigans in order to solve the problem. They were using a deterministic system in order to solve this problem. And it's one thing that I actually did back in college. One of the classes I took was the funny thing was, I think the class was technically called artificial intelligence, but it was pretty much specifically like deterministic AI and using things like heuristics and things like that to basically uh, have more control and certainty over your outcomes rather than kind of a machine learning type artificial intelligence. But if you want to kind of look at deterministic AI and good implementations of it being very smart, you basically have to look no further than video games. And video games are a masterclass at making artificial intelligence and intelligent automated systems while also being deterministic. Because the thing with video games is you want to make sure the game actually works before you ship it. That's kind of one of the poor components of the game. If the game doesn't work, you can't really ship it. I mean, I guess you can nowadays with how, over the air updates work and all that stuff. But in general, at least back in the day when you couldn't just push an over-the-air software update to the game, when they actually came on cartridges and basically what you got was what you got, you needed to make sure the game actually worked. And one great way to make sure the game actually works like you intend it is to write test cases for it. And it's a lot easier to write a test case against a system that is deterministic because you can guarantee what the output will be based on an input. And the way that this is kind of done in video games, it kind of sort of depends on which AI you're kind of, or I guess what specific instance the AI you're trying to solve is being used for. But one of the most common methods for creating an AI for a video game is through things like decision trees and min-maxing to basically give it a state of play, and then you can guarantee what the AI will do assuming you don't program any randomness into it, which depending on the difficulty level, maybe you do. So for instance, if you wanted to make the game a little easier, you probably add a little more randomness to it compared to if you want to make it harder, you add less randomness to it. But if you've never heard of the term min-maxing, it's basically an algorithmic approach where you basically take a tree of possible outcomes. So this is basically your decision tree. So you're given an input state, and then you basically put into a tree every single possible next move, if you will, based on what move you will do. So if I do this, then the opponent can do this, this, or this. If I do that, then the opponent can do this, that, or this. And then basically you kind of make that branched out. So you make that tree. And then you basically just go down the tree and basically add up the scores, right? So if this outcome is positive for me, it gets a positive score. If this outcome is positive for the opponent, then you kind of get a negative score. And kind of the goal of min-maxing is you basically assume that every move that your opponent is making is the optimal choice that they would make. So for instance, if you move say your pawn up a space, and the best move that the opponent could make is to take your pawn, that's basically the choice that you would select in your min-max algorithm as part of that decision logic. You always assume that your opponent is going to be playing optimally. Now, that's not necessarily always the case, but that's generally how the algorithm works and is a very, very good way of ensuring that you're going to succeed and you're going to appear to be extremely intelligent with your system. So again, kind of as the name suggests, you're basically training to minimize your opponent's score while also maximizing your own and assuming that both sides are always playing optimally. Now, this obviously raises the question of what happens if multiple paths in the tree yield the same score. So basically, if I make this move or that move, they're both equally beneficial and I both, basically get the same score out of it. And that's where I guess it depends on how deterministic you want to be. You could have decision logic that say always pick the first one, or always pick the leftmost one, or always pick the rightmost one in the tree, or maybe you just pick randomly based on whatever you're feeling. It doesn't really matter. But if you want to be fully deterministic, you probably would always pick either the leftmost one or the rightmost one in the tree just to make things easier. So I touched on chess a little bit there, and chess is a fantastic example of decision trees and min maxing put to work and how it can be very, very successful. Now, what the thing with chess is there are so many moves that you can make in chess, especially in the very beginning of the game. And it's computationally infeasible to calculate out every single potential move for every single play, right? So if the opponent, moves one of their pawns, you can't feasibly calculate every single move to the end of the game in the allotted time that you can have for a chess game, right? And especially if you're playing this to be kind of like a one-player game, so the user is playing the computer, it's not exactly the best user experience if you make your move and then you have to wait like 30 minutes for the computer to calculate what is potentially the best move before it makes its move. So obviously you can't go all the way through the decision tree, but you can at least go down a few layers to be able to find what the best move is given the current state. So you can basically kind of look a few turns ahead. And if you think about it, if you've ever played chess before, that's basically what all the chess players do anyway. They're basically kind of looking ahead and be like, okay, well, if I move my piece here, then the opponent, they could either do this move to counter it, or if I did that, then they could put me in check, or if I do that, then maybe they'll take my queen, and that's obviously not good. So they're thinking through all these moves ahead of time. So that's basically what you're doing with the computer, with the min-maxing. Now, when it comes to things like chess, this is where things like heuristics come into play. Now, heuristics inherently give a bit of bias, and this is where you could potentially argue that ethics come into play. Like, what do you value more? That's basically what a heuristic is. The heuristic is basically telling the algorithm, hey, this thing is worth more than this thing, so you want to prioritize the first one because it has a higher value. Now, I think in chess it's pretty universally understood which pieces have the most value. But in other types of situations, maybe that's a little more open to interpretation. Or if you wanted to create different difficulty levels, you could adjust those heuristics within the same algorithm to provide different difficulties. Like maybe, for instance, if you wanted to go on super easy mode, all the pieces are worth the same value to the system, so they're not going to prioritize, say, saving their queen, for instance. Whereas in a harder difficulty, they are going to prioritize that. But even still, if you know the heuristic going into it, you still have a deterministic system because you know what the system's going to be weighting things at, so you can add that into your calculation when determining what the output should be. It's only if you don't know the heuristic that it kind of becomes a little more non-deterministic. But again, in this case, if you're writing test cases for a system like this, you're going to know what the heuristics are, so you can factor that in when you're writing your test cases. So, um, the other thing when it comes to another game where this is very evident with the whole min-maxing thing and decision trees is tic-tac-toe. And tic-tac-toe is a much simpler example because it's a much simpler game. And there's a lot less potential avenues that you can go down and a lot less decisions and plays that can be made. So for tic-tac-toe, it is very easy to create the entire decision tree and basically guarantee that you're always going to have the best score and the best move. So, in other words, if you write your AI correctly, the worst that the AI can do is tie. It will never lose. If assuming you wrote your algorithm correctly and everything like that. Because it's very trivial to write an algorithm to play tic-tac-toe. So if you want maybe a fun weekend project, create an AI system to play tic-tac-toe that never loses to you, and the worst it can do is tie. That could potentially be a fun one. So at the end of the day, this is kind of the problem with Gen AI, which all the tech bros are pushing for these days, because Gen AI is inherently non-deterministic. And if you don't believe me, go ahead and pick whatever your favorite AI of choice is currently and ask it the same question over and over again. I can guarantee you will not get the exact same answer twice. I guarantee you. Now, the only exception to that rule is if you say, give it some kind of prompt like, only give me the answer to this mathematical problem. What is 2 plus 2? Then it should spit out 4. And if it doesn't, well, then we have some serious problems. But if you're just asking it a very generic question, you're never going to get the same answer twice. Now, you might get answers that are similar to one another. I would kind of hope you would. But you're not going to get the exact same answer verbatim. In which case, as you can see, it's very hard to test to make sure that your AI is actually producing the outputs that you expect based on the given inputs, because again, it is non-deterministic. And it's even more evident too in things like image generators. You're going to be hard pressed to give an AI the same exact image prompt and get anywhere close to the same image between runs of the prompt. So yeah, so it just makes things inherently hard to test against, which is why modern AI systems have things like guardrails in place to try to keep the AI at least somewhat in line. Although, as people have evidently pointed out in various posts online, it isn't necessarily all that hard to bypass some of these restrictions and get some rather interesting results. But aside from that, there's of course other instances where AI and just ethic-based systems kind of come into play, being the whole non-deterministic thing. Things like robotic systems are generally non-deterministic. Military and defense applications, if there's kind of some ethics involved there. But this is kind of when you get out of the deterministic state of artificial intelligence and move into the non-deterministic state, you basically come into the ethical trolley problem. Now, if you haven't heard of the trolley problem, it is a fantastic it's basically an ethics question that is basically unavoidable if you take any sort of ethics class. And the crux of the problem is, if you are a trolley operator and the trolley is heading to kill, say, 4 or 5, whatever the number of people is, or you can basically pull a lever and it'll divert the trolley and only kill one person, what do you do? And the reason why this is such a hard problem is, if you don't do anything, 4 people die, or however many people. But you weren't technically involved in that because you didn't make any sort of decision to divert the trolley. But if you pull the lever and divert the trolley, then you are responsible for the death of that one person. So which is the ethically right decision? And this has been, in the sphere of ethics debates for I don't know how long time. And it always comes up when whenever you're discussing anything like AI related, because it kind of comes up frequently, and it's an interesting question to ask an artificial intelligence of your choosing, because it'll basically give you a big nothing burger in terms of its answer. But it's even more prevalent in things like self-driving cars, for instance, right? Because it's very plausible that a self-driving car could potentially encounter a situation where will it swerve out of the way to avoid hitting a person, or will it, plow through that person and kill that person and not, run over other people to try to like, not hit the person right in front of them? It's very much now more than ever a problem that we have to deal with. And because these systems are non-deterministic, what are you going to do? Are you going to tell the self-driving car to just plow straight on through? Or are you going to have it try to swerve out of the way and potentially harm these other people on the sidewalk? What are you going to do? Are you going to have it swerve into oncoming traffic and potentially have a head-on collision? There's a lot of things you have to account for, and the big thing in the corporate world is liability. I don't think a lot of people want to be liable for that. So that's kind of a big question mark, especially when it comes to those kinds of artificial intelligence systems or autonomous systems. But then you also have other things too, like any kind of like automated kind of medical things, because what happens if something goes wrong? There's a fantastic example of that. Was it the Theric 25? I think basically this MRI machine, I think it was, and there was a race condition in the code base, which potentially could give way more radiation than what they were supposed to give, and basically ended up killing people because of that. And technically it was just a programming bug because of a race condition, but that was an automated system, and because the automated system wasn't essentially implemented correctly, people died as a result of it. And then, of course, you have things like military applications. That's kind of its own can of worms. But there's tons and tons of algorithms and things that go behind like seekers and how missiles are supposed to identify targets, and there's all kind that's kind of a whole other can of worms. But suffice it to say, there is some sort of autonomy in there, because when you launch a missile, you're not exactly piloting it to make sure it's going to where it's supposed to go. It has systems on board to basically tell it where it should go and how to maneuver, and things like that. um so when it comes to trying to decide the ethics for the system that you're trying to design, assuming it's not deterministic, but I guess even if it is deterministic, this might potentially become things that you have to think about. You have things like utilitarianism, which is essentially the idea that the best action is the one that maximizes happiness or pleasure for the greatest number of people, while minimizing the pain or unhappiness amongst people. And then you have deontological approaches, which is basically the idea that focuses on morality of actions based on different rules rather than the consequences of those actions, and basically emphasizing that certain actions are inherently right or wrong regardless of the outcome. And then you have like virtue ethics. Which is basically character traits to promote ethical behavior in artificial intelligence systems rather than just blindly following rules or evaluating consequences. And this specific approach is more geared towards emphasizing honesty, justice, and responsibility to guide ethical development in AI rather than, things like the deontological one, which is basically like, hey, some things are just not okay to do, so don't do them. One of the problems, I guess, with that argument, though, the whole deontological one, is the trolley problem comes into play, right? What are you going to do? Are you going to intentionally kill someone, or are you just going to let it kill someone or multiple people and, kind of wipe your hands because you technically didn't do anything to make that happen? It was just going to happen anyway if you didn't intervene. So tons of ethical dilemmas that people can talk about till they're blue in the face over. So this is kind of the thing, that the challenge when designing these systems is these always creep in when you're trying to design a system, especially systems that potentially have life and death consequences if they're not done correctly. But then you also get into other things like bias in autonomous systems. Now, you could argue that in even in deterministic solutions like the min-max algorithm we talked about, when you're creating your heuristics, you're inherently adding bias to that system by saying, hey, system, you should prioritize this thing over this thing. This thing values more than that thing. So technically, even in deterministic systems, you are adding your bias in there, although depending on the system, especially in video games, I think it's generally pretty easily understood why certain things have more value than others. It's pretty clear why in chess the queen is more valuable than a pawn, or why the king is the most valuable piece on the board, because if you lose your king, well, you lose the game. So this is kind of some things that have to um, influence how you design your algorithms. And if we're being honest, it is very hard to remove personal biases when designing systems, especially if the systems that you're designing have real world impacts. Now, if you're designing a fun video game on the side where none of this really matters, who's to say that you have any sort of bias at all? I mean, you're just making the game mechanics as you see fit. But if you're creating some sort of system that does have impacts and touches the real world, these are things that you definitely do have to be cognizant of, because um, like I said, we all have our own unconscious biases, whether that's because that's just what we know to be normal, that's just how we grew up. We all grew up in different environments. We all, like it still amazes me. Like one time when I was in college, for me, it wasn't weird to grow up in a county that had multiple high schools. But when I went to college, one of my friends in college, he thought it was. He kind of looked at me with like a confused look when I asked him like what school did he go to in his county, because he was like, there was a choice. There's only one. So there's different. We all grow up differently. We all have different views of the world, and while we might not think we're imputing any sort of bias as we're developing things, we kind of inherently are, even if we're not trying to. Now, a couple ways that you could potentially try to mitigate this is things like code reviews and design reviews, with multiple different people involved. So it's not just you. You have kind of differing opinions kind of all going into creating this system. But I think at the end of the day, if you're a developer implementing this system, like I know for me personally, if I was tasked with designing an autonomous vehicle system, right? If I was tasked with that, I would be like, okay, well, I have some ground rules here. You are going to tell me what I need to program into this system if it encounters X, Y, and Z. If the system is approaching an intersection and it sees a car speeding through the intersection, what are we doing? Tell me what I need the system to do. I'm not making that decision because I don't want that on my conscience. I want to be as far removed from that decision as possible. And this is kind of where the whole liability and accountability comes in, which we kind of touched on earlier, because there are all sorts of legal issues that kind of creep up when you're talking about autonomous systems in the real world. Now, I think it's safe to say that if you're designing an autonomous system for the real world, you want to make sure it's as objective as possible. And that can be very hard because, as we just talked about, us humans are inherently biased, right? But if you can make it as objective as possible and you can point to, actual statistical data or some sort of factual based evidence for your decision making, that becomes a lot easier to defend in the event that something goes wrong or someone gets mad at you because your system behaved a certain way. You can point to, your stack of evidence or the stack of, different parameters that were fed into the system that made it decide that that was indeed the best decision, and it was a better decision than this other thing that could have happened, should we have, not done the thing, right? So going back to the trolley problem, yes, one person died, but if we didn't make that executive decision, then four other people would have died, and that's obviously not good either. So we made the lesser of the two evils and only harmed one person. I know this is very morbid, talking about the trolley problem, but it's a fantastic way to kind of talk about the complexities of how this isn't just a black and white, just create a system that does the thing, because there's a lot of conceptual things that you have to think about when designing very complex autonomous systems like this. Um, so this is kind of going back to the whole liability thing. The whole, like, who is responsible if something goes wrong is something that the lawyers at these various companies are working hard on to basically remove themselves entirely, as much as they can anyway, from any sort of blame and liability, because the last thing they want is for, say, their autonomous vehicle to end up in a car crash, someone gets potentially seriously injured and tries to sue the company for damages because they got hurt while in this autonomous vehicle. Now obviously the company isn't going to want to pay anything because they obviously want to keep as much money in their pocket as they can. But then again, it comes down to who is actually liable for that. Now the company might try to throw some kind of like user license, well, I guess maybe not license agreement's the right thing, but some kind of terms of service, like, hey, by the way, if you use our autonomous vehicle service for getting around and you get in an accident, you can't sue us. So by signing this agreement or by stepping into the car, you inherently agree to these terms and you aren't able to sue us. So this is kind of where the whole legalese come in to basically cover their behinds. Um, but again, it is something that you also have to keep in mind when, uh, I guess, releasing these autonomous systems to the real world. And it doesn't necessarily only have to be for autonomous vehicles. If you have, say, robots in assembly lines, sure, for the most part, the robots can be fairly deterministic in their actions. But what if the part it's expecting to get there doesn't get there when it's expecting because the assembly line got slowed down a little bit? It's obviously going to have some sort of logic in place to know that it has to wait for the thing and not just keep going willy-nilly and potentially because maybe for instance the part weighs a significant amount of weight. Maybe it weighs a few hundred pounds or something. So the movement in the robotic arm to move that piece is assuming that it has 100, say 200 pounds on it attached to itself while it's moving, so it applies a certain amount of force. But if that object isn't there, it might overly swing because it's a lot less, there's a lot less weight there, and it might end up hitting someone because it, as far as it's concerned, it's just doing what it's supposed to do, but of course there's no part there. So having some sort of, in that case, it is kind of, you do kind of have to make it a little non-deterministic, in the sense that you don't necessarily always know that you're going to have an object there for it to pick up. So you kind of have to have this kind of waiting period to make sure there's actually something there to pick up before you move. And there's a, like I said, there's a whole lot of things you have to take into account when designing these systems. And that would also be an instance where there potentially could be a liability concern if the robotic arm, say, didn't actually pick up anything and swung too far because it applied the same amount of force it always does, but it obviously had less weight, and then hit someone, and that person has to go to the hospital because they got whacked upside the head by this big robotic arm. And I don't know about you, but I think if I was, working on an assembly line and got whacked in the head by a robotic arm, not because I was, not standing where I wasn't supposed to, but I was just standing where I was supposed to and still got whacked anyway, I'd probably be pretty mad and might want to try to sue the company or try to get some kind of workers' comp or something. So like I said, it's not just like autonomous vehicles that these kind of ethical decisions kind of come into play, and the whole liability issue becomes a factor. Um, so The other, I guess, potential issue that's coming up with the whole ethics debate when it comes to autonomous systems is how people interact with them. And this is becoming very, very evident with how people are interacting with, things like large language models, right? And how the human actually interacts with the system itself. What does the interface look like? In the case of large language models, it's basically just a prompt that you type in whatever you want and it'll spit out whatever you want. But for autonomous vehicles, it's a little bit different. You're not necessarily providing much user input per se. And the other issue is the whole over reliance factor on these systems. And even take out fully autonomous cars for a second. Just imagine modern cars with all of their safety features. I have seen people posting that they don't want cars with all these safety features or want the ability to turn them off because they don't want to become over reliant on these systems. Because if you become over reliant on these systems and they fail, well, now you're kind of out of luck. So that is one potential concern with these very autonomous systems in our daily lives is we tend to become over reliant on them. I think this can probably be very evident in the number of people that basically are resorting to whatever their large language model of choice is, asking it a question, and then taking that answer as the gospel truth, which, as we've discussed many times on this podcast, is a very, very bad idea, but it still happens nonetheless. So that is kind of one thing you have to be mindful of. And again, depending on how these systems were designed, what ethical boundaries they included, there's potentially a chance that maybe they don't necessarily have your best interest at heart when giving you a response. And then the other thing you also have to consider too is how are these systems trained? Because in the cases of, say, self driving cars, large language models, they have to be trained on data. And again, it comes down to the age old adage, if you're not paying for the product, then you are the product. If you're using a large language model and you're not paying for it, well, it's all basically a guaranteed fact that it's harvesting every single query you have and every output it gives you in order to train itself for future training. And it's the same thing with, image generation models. Where is it getting its image data from? Is it being purchased in a responsible manner? Is it being pirated? Who knows? You can potentially get into some gray areas there. But again, the other issue with the training data is it's only your output's only going to be as good as your training input. So if your training data is very bad, you're obviously not going to have very good output. So but the other thing with the training data is if you've looked at how these models are trained, you get into this. There's basically a I'm trying to remember what the word is or the phrase is, but you basically get to the point where if you train too much on the training data, your performance drops significantly because the AI only recognizes things in the training data and can't generalize things. So when it is met with something that isn't in the training data set, it has no idea what to do. So if you needed any more proof that these AI systems are just very dumb, there's another one for you. So you basically have to find the sweet spot of training it enough so it can make generalizations, but not overtraining it to the point where it only recognizes the training data. But the problem is, because you kind of have to find this sweet spot, you're never going to get a perfect 100% match rate for the AI system to give the correct result, which is why we always see these things like hallucinations and AI basically making things up that doesn't exist. But also talking about the whole ethical boundaries thing, inherently, when people are designing these AI systems, they are inherently adding their own biases into them as to how they want them to respond to certain instances. So, for instance, back when the whole DeepSeek thing was coming out, the whole AI model from China that kind of blew up the internet because it was like, oh man, this AI model is so dang good and it's better than Chat GPT, and it used significantly less time to train and all this stuff, and that's its own can of worms. But the point is, the actual version of the model, like in China, had so many guardrails on it and was so restrictive to basically kowtowing to the Chinese Communist Party, right? Like it would only talk about them in a good light, and if you tried to kind of circumvent that, it wouldn't do anything for you. But if you kind of just got the raw model itself and kind of ran it in, say, your home lab, where those guardrails weren't on, it was very open to kind of being more responsive. So whenever you're dealing with these AI systems that are trained by someone else, there's almost always some sort of guardrails put in place that have some sort of biases by whoever developed it for whatever their purpose is. You probably don't know what that purpose is, and you might not necessarily be able to uh, diagnose it right away. But that's kind of the nature of the whole idea of propaganda, right? In a sense, where if that's all you're fed and that's all you just kind of assume that that's how things are, when in reality, maybe there's a little spin here, maybe a little spin there, maybe twist this idea a little bit that way, maybe put a little more of a positive light on this so it doesn't sound as bad. Maybe if I say it this way a little bit differently, then it doesn't sound as bad and puts, this in a little bit of a better light, things like that. And that's how you can basically tweak and modify these models to basically give the certain perception or point of view that you want them to portray. And that's kind of where the ethics come into play of how much guardrails should we actually be putting on these systems, and is it okay to filter out certain types of responses and all those kinds of things. So these are the kinds of questions that you kind of have to be thinking about and be mindful of when you're using these systems. So I know that was kind of a very big rambly mess, but hopefully you at least got something out of it. Hopefully you learned a little bit of something, and prioritize making deterministic systems because they just make life so much easier. I know they're not as generic and universal as things like Gen AI models, but at the end of the day, like I said, you can make some very, very intelligent systems that are deterministic, that you can guarantee, what your output is going to be based on what you give it. So yeah. But before we wrap up for today, let us return to our trivia question for the week. So this week's trivia question is: the original x86 chips, or the 8086 and the 8080, had a total of how many different instructions that they could perform? So how many different instructions could the original Intel x86 chips perform? If you said 81, congratulations, you got this week's trivia question correct. And that's going to do it for this episode. So if you enjoyed it, definitely be sure to leave it a rating and review, and subscribe if you haven't done so already, especially if you learned something. And if you learned something, a friend or family member would probably learn something too. So definitely be sure to share it with them. And I know we touched on a lot in this episode. So if you have any questions, comments, or ideas for future episodes, if you're on YouTube, you can leave a comment down below, or if you're on podcast, you can shoot me an email at contact@darkassassinsinc.com. The link for that is down in the show notes below as always. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.